their fever had subsided and the answers could be yes or no, then the percentage who said yes should match the null hypothesis. Poison data. Evaluate rate of occurrence of frequency. If the sample is asked about how many times in a month they use the medicine, and the rate of frequency is recorded and is then compared to the null hypothesis, where the rate should be less than a certain number. Let's understand the different types of variables to analyze categorical data. Nominal variables have values with no logical ordering. They are independent of each other, and the sequence does not matter. For example, in a restaurant, you can order burgers, soda, and coffee in any order. Ordinal variables have values in logical order. However, the relative distance between the two data values is not clear. For example, large, medium, and small coffee sizes. Association indicates that two variables are associated or independent of each other. For example, in the first dataset, weather does not affect the train schedule, but in the second dataset, it does. Variables have dependencies, and one changes if the other changes. Chi-square test is a hypothesis test that compares the observation distribution of your data to an expected distribution of data. The test is applied usually when there are two categorical variables from a single population. It's used to determine whether there is a significant association between the two variables. Chi-square test is used to test the independence or association between categorical variables. Determine whether a statistical model fits the data adequately. Let's understand the chi-square test through an example. We have a data set of male purchasers and female purchasers. Let's assess whether probability of females purchasing items of $500 or more, or 0.45, is significantly different from the probability of males purchasing items of $500 or more, or 0.25. Null hypothesis. There is no association between gender and purchase. The probability of purchase does not change for $500 or more, whether female or male. Alternative hypothesis. There is association between gender and purchase. The probability of purchase over $500 is different for female and male. Let's look at the types of frequencies. Expected frequencies, or FE. The cell frequencies that are expected in a bivariate table if the two tables are statistically independent. Observed frequencies, or FO. There is association between gender and purchase. The probability of purchase behavior over $500 is different for female and male. If there is no association between gender and purchase, then the observed frequency would be equal to the expected frequency. If there was an association between gender and purchase behavior, then the observed frequency will not be equal to the expected frequency. The formula for calculating them using chi-square method is shown here. Chi-square is calculated using the formula shown on the screen. Chi-square is the sum of the squared difference between the observed frequency and the expected frequency data, or the deviation, divided by the expected frequency data in all possible categories. Expected and observed frequencies require no assumption of the underlying population. Both the frequencies demand random sampling. Let's understand the correlation matrix. A simple matrix can be visualized as an Excel document with 3 rows and 3 columns. A correlation matrix is always a square matrix. That is, it has the same number of rows and columns, but it's a larger set. A correlation matrix is expressed in the form of an NXN matrix when we compare n variables. The covariance is calculated by getting the sample variance between the variables in question. A correlation coefficient measures the extent to which two variables tend to change together. The coefficient describes both the strength and the direction of the relationship. Pearson product moment correlation. The Pearson correlation evaluates the linear relationship between two continuous variables. A relationship is linear when a change in one variable is associated with a proportional change in the other variable. Spearman rank order correlation. Also called Spearman's row, the Spearman correlation evaluates the monotonic relationship between two continuous or ordinal variables. In a monotonic relationship, the variables tend to change together, though not necessarily at a constant rate. The Spearman correlation coefficient is based on the ranked values for each variable rather than the raw data. Here is the example of a correlation matrix calculated for the stock market. We can choose the data variables and calculate the correlation matrix to demonstrate the short, medium, and long-term relationships between them. Now you can see why a correlation matrix would prove useful for traders. We already know that inferential statistics uses a random sample from the data to make inferences about the population. This is a valuable method when each and every member of the population cannot be studied. Inferential statistics can be used only under the following conditions. You have a complete list of the members of the population. You draw a random sample from this population. Using a pre-established formula, you determine that your sample size is large enough. Inferential statistics can be used even if your data does not meet these criteria. Inferential statistics can help determine the strength of the relationship with your sample. If it's very difficult to obtain a population list and/or draw a random sample, then you do the best you can with what you have. Inferential statistics is an effective forecasting tool widely used in businesses. For example, companies use it to predict their finances for future quarters. Using current data, future patterns can be inferred. Let's now quickly recap what we've learned in the lesson. Statistics is the study of the collection, analysis, interpretation, presentation, and organization of data. Statistical analysis is more reliable, as it is based on numbers and scientific analysis when compared to non-statistical analysis. Descriptive and inferential are the two major categories of statistics. Descriptive takes into account all the members of the population, while inferential uses only a sample. Mean, median, and mode are measures of central tendency, while variance and standard deviation measure the spread of data. The spread of distribution is called dispersion and is graphically represented by a histogram and a bell curve. The shape of the dispersion is represented as left-skewed, right-skewed, and kurtosis. Hypothesis testing is an inferential statistical technique that is useful for forecasting future patterns. Chi-square test is a hypothesis test that compares observed distribution to an expected distribution. The correlation coefficient or covariance measured with the help of correlation matrix measures the extent to which two variables tend to change together. This concludes the lesson, Statistical Analysis and Business Applications. The next lesson will discuss Python environment setup.